ViewBite.
Have you ever stopped to marvel at a sunset so vibrant it seems as though the sky is on fire? This mesmerizing phenomenon isn't just a stroke of luck, it's a spectacular display of science in action. The colors of a sunset are primarily the result of a process known as Rayleigh scattering, where sunlight is scattered by the gases and particles in the Earth's atmosphere. During the day, the sky appears blue because shorter wavelengths of light, like blue and violet, are scattered in all directions more than other colors. But as the sun sets, its light must pass through a greater thickness of the Earth's atmosphere, scattering the shorter wavelengths and leaving the longer wavelengths, like red, orange, and pink, to dominate the sky. The presence of particles such as dust, smoke, and water droplets can amplify this effect, acting like a prism that further disperses the sunlight into a spectrum of stunning colors. High-altitude clouds can catch these colors and reflect them back to the ground, adding layers and texture to the sunset. The angle of the sun also plays a crucial role. At sunset, sunlight strikes the atmosphere at a more oblique angle, increasing the distance the light travels and enhancing the scattering effect. Atmospheric conditions, including humidity and temperature, can influence the intensity and hue of the sunset, making some evenings more colorful than others. Pollution and volcanic eruptions can contribute to more vivid sunsets by increasing the number of scattering particles in the atmosphere. Interestingly, the cleanest air can sometimes produce the least colorful sunsets because there are fewer particles to scatter the light. This balance between purity and particles creates a canvas where nature paints its most breathtaking scenes. The next time you witness a fiery sunset, take a moment to appreciate the complex interplay of physics, chemistry, and meteorology that makes it possible. It's a daily reminder of the planet's beauty and the intricate systems that govern our natural world. From the golden hues that bathe the savanna to the deep purples that crown mountain peaks, every sunset tells a story of light's journey through the atmosphere. Understanding the science behind these celestial artworks doesn't diminish their magic. If anything, it adds to the wonder. So whether you're watching the sun dip below the horizon from a bustling city or a quiet beach, remember that you're witnessing one of nature's most exquisite performances, a symphony of light and air. The variations in sunset colors can also indicate the weather to come. A red sky at night often signifies high pressure and stable air coming in from the west, which usually means good weather is on the way. Conversely, a red sky in the morning can be a sailor's warning, as it may indicate that the good weather has passed and a storm system is approaching from the east. These ancient weather sayings hold a kernel of truth, rooted in the observation of how light interacts with the atmosphere under different conditions. Beyond their beauty, sunsets serve as a natural barometer, offering clues about the atmospheric conditions that shape our weather. The study of sunsets not only satisfies our curiosity about the natural world, but also enhances our connection to the environment, reminding us of the delicate balance that sustains life on Earth. As the sun sets, casting its final golden rays across the landscape, it invites reflection on the day that has passed and the promise of a new dawn. In every sunset, there is a story of endings and beginnings, of science and beauty intertwined in the evening sky.
ViewBite. Quick clips, big ideas. Subscribe and spark your next thought.